Welcome back to It Ain't Rocket Science. I'm Adam Balkin. We are now in Times Square, and if there is any place on the globe that requires lots and lots and lots of energy, this is no doubt it, with all these big ads and bright lights. But it's precisely because of all those bright lights that this whole place might actually be just one giant advertisement for our desperate need for greener energy sources. If a solution exists for perhaps the world's two most pressing and interconnected issues, the environment and energy, there's a good chance that solution or solutions will emerge from here, the National Renewable Energy Lab in Golden, Colorado, the only federal lab where green energy technologies are exclusively being researched, developed, and made ready for widespread everyday use.
Our mission is to basically look at different kinds of technologies for renewable energy. So the lab's portfolio spans a whole bunch of different things. How do we get basically better battery technologies for electric cars or hybrid vehicles? How do we generate wind power more effectively, and how do we integrate that with the grid? How do we do photoconversion? And how do we integrate that in the grid so that people can really take advantage of that and use it, the municipalities can use it as part of their electric portfolio?
Now, when most of us think of alternative fuels, we probably think of solar power and wind power, but do you ever think of plant power? In this section of the facility, researchers grow and examine different types of algae for producing power while cleaning our air.
They take the energy from the sun, CO2 from the air. They take those energy sources and that carbon input, and they turn that into oils, or what we call them lipids. Those turn out to be very dense forms of energy. So if you can take those back out of the algae, you do some basic chemistry on them, and essentially what you end up with is biodiesel. The CO2 will go back into the atmosphere, but we're trying to establish like recycling of that rather than just pulling oil up out of the ground and releasing that CO2.
And as for how the government uses this facility to generate some income for the taxpayer's investment, oftentimes, if a technological breakthrough is made here, that innovation is then licensed out to a private manufacturer, which can then try to mass produce the next green IT product. But you don't have to wait until you're a full-blown scientist to start thinking about our energy problems. Some kids we met are working on solutions right now.
National 4-H the past 4 years has done a National 4-H science experiment, and we really felt we had a good idea for this experiment this year. They kind of wanted it to focus on renewable energy, so we wrote a wind experiment for them, and they really liked it, and we thought it was good, and it was selected as a National 4-H science experiment. Have you ever seen a big wind turbine? What do the blades look like? They're long and white blades. And so what we're going to do is see if this type is better than this type, right? The kids are going to be building two different types of wind turbines. In particular, they build the blades for the wind turbines. In the process, they learn about engineering design and design constraints and how to design those blades.
Trying to make something kind of like a fan. Well, you cut out blades and then you glue them on sticks and you put it on this sort of wind projector and you put it in front of a fan and see how much energy it makes. They're propellers.
And what do you do with them?
You put them on a windmill.
And then what happens?
It makes electricity.
This experiment is so great for kids, and some of that is because it's got moving parts. It's got lots of stuff that's moving that both draws their eye, draws their attention, and that they get to build. And so they get their hands on something, they get to build it, and then they get to test it. And something that they get to test that moves.
I'm poking holes in the cup so then I can put these through it and make it like a fan type thing. And so then if you blow the wind into these, then it'll make it spin around.
You guys did a really simple test, an experiment, experimenting between this type of blade and this type of blade, and discovered that this type of blade was better. So they learn about engineering design, but also about renewable energy and how that these wind turbines are designed. And they can see from the experiments that they do in their small scale little experiments using a fan for wind, they can see which designs are better, and that translates to the real world.
Well, keep in mind, you never know where some of these interests will lead. We recently caught up with a man who had some scientific hobbies as a kid and used some of those skills to make movies, some of the most successful movies of all time. Movies like Titanic and Avatar. When you think of James Cameron, chances are you think of movies he made like Titanic, Avatar, but do you think of him as a technologist? Well, the folks at Popular Mechanics are among those who do, which is why they honored him at their annual Breakthrough Awards for not only creating cutting-edge new ways to create 3D movies, but for applying those methods towards also capturing footage throughout the oceans. And next up, he's trying to get it aboard a Mars rover.
I love exploration. When I was a kid, it was the golden age of space and ocean exploration. Jacques Cousteau and the Apollo program, and I was bitten by the bug then. When I was in college, I thought I wanted to be a scientist. I changed to the arts and became a storyteller, and I've sort of circled back around.
Cameron wasn't the only person turning heads at the ceremony, though. This is Rob Summers, paralyzed from the neck down in 2006 by a hit-and-run driver. Researchers at the University of Louisville made him the first person to be implanted with this electric nerve stimulator in his spine.
I was able to stand on the third day completely independently, and within 6 months of using the stimulator in therapy settings, with the stimulator on, I can control the movements of my toes, ankles, knees, and hips.
Other innovations honored this year range from everything from personal electronics to large-scale avionics. This is BoroPure roof tile that, through a chemical reaction, not only neutralizes smog, but turns it into a low-grade fertilizer so that when it rains, the byproduct runs off and feeds the grass below.
If we drive about 11,000 miles per year, this will neutralize the smog.
And when you think of high-tech pieces of military equipment, have you ever thought of something like a hummingbird?
3, 2, 1. Funded by DARPA. The idea was to use biomimicry, design something that looks or operates like a real biological thing to do a useful military mission.
And likely that mission will be to quickly fly into potentially dangerous areas and perform video surveillance before troops move in. You can visit Time Warner Cable's Connect a Million Minds website to find out more about the initiative and take the pledge to help inspire young minds to become tomorrow's problem solvers. And so, from here in Orlando at the 100-year Starship Symposium, where the debate continues over whether to go to Mars or Jupiter or an asteroid and how exactly we're going to get there, I'm Adam Balkin for It Ain't Rocket Science.